All right, letter A, we get negative 900. Basically, because this turns into a positive 100, and this is a negative 1,000. Negative 1,000 minus, take away 100, is negative 900, okay? 8 divided by 4 is 2, and then we do the subtracting. 6 minus 3 is 10 cubed. Okay, this one you might have forgotten that there are two answers to this. 10 or negative 10 will make 100 when you square it. Okay, converting 50 degrees to Fahrenheit, we get 122 degrees Fahrenheit. What I did was divide by 5, multiply by 9, and add 32. Okay, 25% of 1,000 is a fourth, 25% of 2,000 is a fourth of 2,000, which is 500. So then you take 500 away, add it to there, and we get $2,500. Okay. All right, now we've got a right triangle here, and I know it's a right triangle because it follows the Pythagorean Theorem, meaning this squared plus this squared equals that squared. And we're going to explain why that is important. Like in the book, it tells us that workers who construct buildings need to be sure that they have square corners, that this is truly a square corner, because if your building is leaning even by 1 degree, then the other end of the building will be about 8 inches out of position, and that's significant in construction, so they need to be very perfect on this. One way they can check whether a building under construction is square is by using a Pythagorean triple. Okay, they call it a triplet in the book. I've always heard it as triple. Okay, they use triplet. And 3, 4, 5 follows the Pythagorean is a triple. Okay, and these are special numbers where without any decimals they're nice perfect, because 3 squared plus 4 squared equals 5 squared, which is 25. So 9 plus 16 equals 25. So they follow Pythagorean Pythagorean Theorem. So we call that, here's one of the triples. 3, 5, 3, 4, 5 is a triple. Okay. So if construction workers measured this and then measured the distance between the ends, and they were a Pythagorean triple, then they know they have a square side there, which is what they want. Multiples of 3, 4, 5 are also triples that are always going to work. Okay, what I mean is, what if we doubled all these? 6, 8, 10. Those are all Pythagorean triples. Okay, if you have a 6, 8, and 10, you know you have a right triangle. Okay, if you have, what if we triple all these? So we get 9, 12, 15 is also a Pythagorean triple. And then let's multiply them all by a multiple of 4. So we got 12, 16, and 20. And we can keep going on and on and on. So these are all some special numbers. Okay, so there's a little scenario on that about finding perpendicular sides and an activity. Okay, and that requires a ruler, a protractor, 2 full-length unsharpened pencils, and you can do the activity. If you show me that you did it, maybe draw some pictures that show me how you did it, then I would gladly give you some extra credit. Okay? All right, but it's not necessary. Just read what they do. All right, now let's look at example 1. The numbers 5, 12, and 13 are a triplet because 5 squared plus 12 squared equals 13 squared. So that's not one of these, but it's a different one. Okay? So I'm just going to write that 5, 12, and 13 are also a Pythagorean triple. That means 10, 24, and 26, right? If we double all those, that would be the next 3 multiples of this triplet. So double all of them, we get 10, 24, 26. And then if we multiply them by 3, we get 15, 36, 39, right? Multiply them all by 4. You might be getting nervous about that 13, but I'm going to give you a trick for remembering some of your 13s. I don't like how I wrote that 24. There we go. So times 4 is 20. 12 times 4 is 48. 13 times 4. Now remember, one suit in a deck of cards has 13 cards, and there are 4 suits in a deck of cards, and there are 52 cards, so 13 times 4 is 52. That's how I know my 13ths. Okay, example 2. A roof is being built over a 24-foot wide room. Okay, I'm going to show you this. We'll draw it. Okay, a roof is being built over a 24-foot wide room. Okay, so go ahead and draw this. Okay, the slope of the roof is 4 inches 12. Okay, the slope is 4 inches 12. Okay, what they mean by that is this is up 4 over 12. I don't know why they did it that way, but anyway, we'll go off the picture. 4 and 12. Okay, and then we're supposed to calculate the length of the rafters needed for the roof. And then they say go ahead and include 2 feet for the rafter tail. Okay, so here is my tail, or here is our tail, and this needs to be 2 feet. So what we do here is we're looking for the length of that, right? So this is a 412. Now we need to know what the hypotenuse would be. So and this is the right angle. So we get 4 squared plus 12 squared equals c squared. Okay, so what we get is 16 plus 144 equals c squared, which is going to get us 160 equals c squared. So the square root of that, though, is going to be the length of the rafter, right? The book went ahead and used a calculator to figure out the square root of 160 is because it's not a perfect square, and that is about, remember I have to say about 1,265 feet is about the length of our C here. Okay, here's C. Then we have to add this 2 feet for the tail, okay? So we're going to go ahead and say 12.65 plus about 2 equals 14.65 feet. Okay. And the book went ahead and figured out what that is with inches, because we don't usually do decimals with the kind of system we use with this U.S. standard system. So 0.65 feet, okay, how many inches is that? Well, what we do here is say, we're going to say 0.65 feet. In the conversion, 1 foot is 12 inches, okay? So what we're going to do is do 0.65 times 12 to get how many inches we have. And when we do that, we get, I would do it off to the side, 0.65 times 12, and we get 7.8, okay? So our final answer is 14 feet and 7.8 inches, yes. So we'd say, we'd round, I guess, 14 feet, about 14 feet, 8 inches. And I'm going to do the squiggle there. Okay. Alita went to a level field to fly a kite. She let out, I'm going to go ahead and draw her here. Hi, so happy. She's going to fly a kite, and she's going to let out, and we're going to go ahead and just have it pretend like she's doing it from the ground. It's easier that way, and they didn't specify. Oh yeah, it's on a stake from the ground. She ties it to a stake. Okay, there's 200 feet of string, and then she walked out on the field until she was right under the kite. She walks straight under the kite there, right? So this should be a right angle. She's straight under that kite. And she is 150 feet away from the stake. So we're going to write 150 feet here, right? And with those measurements, we know how much strength she had. Now we know how far away from the stake she is. We can figure out how high up that kite is. Okay, so we go a squared plus b squared equals c squared. So let's call that b. Okay, so 150 squared plus b squared equals 200 squared. Okay, and I'm just going to let you know we're going to need a calculator to find the square root for this one because it's not going to be perfect. So 150 squared, well, 15 times 15 is 225. So what that is 22,500 plus b squared equals, and that is 40,000. Okay, because 2 times 2 is 4, and then we've got, 40,000, I forgot a 0. So we get 4 zeros. Okay, so let's go ahead and solve this equation. We need to get this down to b squared, right? So let's subtract 22,500 from both sides. Okay, and when we isolate that b squared, we get b squared equals 17,500. Okay, but now is when we would use a calculator. Okay, because b is going to equal the square root of that. Okay, and when we plug that into our calculator with a square root sign, if you have one, an iPhone tipped sideways is a scientific calculator that can do square root on that calculator feature. So I don't know if you all know that yet. So our b is about equal to, when we calculate it through, 132 feet. So that's how high up that kite is. Okay, so now you get to practice this. I think we only have 2 practices, which is kind of sad for you, sad for me, happy for you maybe, unless you like this. Okay, go ahead and draw pictures to help you with these word problems, okay? And you can come back and see if you do it well, if you get stuck, or use the solution key, all right? And you may begin. Okay, we have a 12-foot ladder leading against a building. So I'm going to draw. What that makes is a triangle, and we have a 12-foot ladder leaning against a building. The base of the ladder is 5 feet away from that building. Okay, how high up the side of the building does the ladder reach? And again, I'm going to give that a B. Okay, and then we're going to try and convert it to feet and inches, round it to the nearest inch. Okay, so what I get is 5 squared plus b squared equals 12 squared. Okay, and that is 25 plus b squared equals 144. Okay, we're going to subtract the 25 from both sides, and we get b squared equals, and we get 119, right? Well, 119, when we find the square root of that in our calculator, is, well, actually, I'm going to write this because I want you to get used to this line. Your b equals the square root of 119. Now remember, there's no plus or minus in this because this is real measurement, and there is no negative answer. Okay, so b is about 10.9 feet. Okay, but we're not done because we need to know what 0.9 is according to inches. So we're going to say 0.9 feet times 1 foot is 12 inches. Okay, so 0.9 times 12 is going to give us, let's see, 9 times 12 is 108, right? So 9.9 times 12 is going to be 10.8 inches, right? Well, 10.8 will be about 11 inches. So altogether, he's got 10 feet and 11 inches. Or the height of the ladder is up 10 feet, 11 inches. I'm going to say about. Okay. All right, letter B. Okay. This is a quadrilateral ABCD, illustrates a rectangular field 400 feet long and 300 feet wide. Okay, 400 feet long and 300 feet wide. Okay, the path from A to C is how much shorter than the path from A to B to C? Okay, so if you were, let's say this was a football field and your coach said, run the corners, okay? How much farther, if you didn't run the corners, if you had to run from here to here to here, or if you had cut across, how much farther is it when you go all the way, or rather than cutting the diagonal, okay? So we're going to find two distances here. Basically, we know when we go A to B to C, let's just write it. A to B to C is 700 feet, right? And so let's see now how far it is from here to here. Okay, I'm going to call that C. Even though we've got A, B's, and C's, so we're just going to realize that has to be the length. So we're going to do 300 squared plus 400 squared equals C squared. Okay, now if it helps, I'm going to show you something. Back to the Pythagorean triple, 3, 4, 5. Isn't 300, 400 a multiple of 3 and 4? So if 300 plus 400 equals 300 squared plus 400 squared equals 500 squared is what I'm trying to tell you, because they are multiples of the triple. Okay, but we can double check that. I know that because 3 squared plus 4 squared equals 5 squared, and this is a multiple of all of them, C is going to be 500. I said that 100 times in a different way, sorry. Okay, so we get 900 plus 1600 equals C squared. Well, there we go, 2500 equals C squared. C equals the square root of 2500, which is 500, isn't it? And that's nice because it's one of the triples, okay? So from here to here is 500 feet, right? So now the question goes back to the path from A to C is how much shorter than ABC. It is 200 feet shorter. All right, sorry I was so wordy on that. That is it for today.